All right, today's lesson is 64, using a unit multiplier to convert a rate. Today we're going to learn how to take rates like 60 miles per hour, and we're going to learn how to change that into another unit. In other words, maybe instead of 60 miles per hour, maybe 60 yards per hour, or 60 feet per hour, or maybe 60 miles per minute. So that's what we're going to learn how to do today. So a unit multiplier is something that's a known fact about two units. 60 minutes equals 1 hour, 5,280 feet equals 1 mile, a mile equals 1,760 yards. So the pattern that we use to convert one unit rate, or one rate to another rate, is by multiplying the given rate by a known fact as a fraction, and then we get a converted rate. So let's do that in the first example. It says convert 60 miles per hour to miles per minute. 60 miles per hour, we times it by a unit multiplier. We want to go to miles per minute. Keep in mind, if it says MI, that's miles. If I took off the I, that would be meters. If I add the N, that's minutes. So miles per hour, miles per minute. Notice, miles and miles did not change. If I'm given hours, though, I'm going to change my hours into minutes. So how do I convert hours to minutes? I have to decide, does hours go on the top, the numerator, or the denominator? So here's how you know. If you want hours to go away and end in minutes, then you need hours to cancel. So I'm going to have hours on the numerator because hours was on the denominator. If I have the same unit on top and bottom, I know that they're going to cancel. On the bottom, I want to be left with minutes, so I put minutes. So now if I put the known fact, I know that there's 60 minutes in 1 hour. So I multiply 60 times 1. Hours and hours cancel, they turn into 1. And I get 60 divided by 60. And that reduces to 1 mile per minute. Make sure it makes sense. Is 60 miles per 1 hour equivalent to 1 mile per minute? That makes sense. So let's do the next one. So in the next one, Jasmine ran a mile in 6 minutes. Use a unit multiplier to find her rate in miles per hour. So let's write, she runs 1 mile in 6 minutes. Multiplier goes there. And I want to end up in miles per hour. So I look at what I'm given and where I'm going. I'm given a mile. I'm going to end in miles, so don't convert your miles. But I started in minutes. I want to end in hours, so I'm going to convert minutes to hours. So I know one of these is minutes and one of these is hours. How do I know where they go? Since minutes is on the denominator, I want minutes to go in the numerator so that they'll cancel out. I know hours should end in the bottom, so I put hours on the bottom here, or denominator. So minutes cancel. I know my known fact, there are 60 minutes in 1 hour. I multiply across. 1 times 60 is 60, and 6 times 1 is 6. I always simplify any fraction that I get here, so I'm going to get 6 goes into 60 10 times, 10 miles per hour. So this is Jasmine. We're going to use Jasmine's number in the next example, so I'm going to leave that number there. The next example says, determine the unit multipliers that would allow us to convert miles per hour to feet per hour. So, and it says to use Jasmine's. So we're going to start with Jasmine's. 10 miles per hour. We're going to convert that to feet per hour. All right, so notice hours and hours. They stayed the same, so don't change the hours. But what did change is miles and feet. So I need to think of a converter where one of them is miles and one of them is feet. Let's see. I do know a known fact that there's 5,280 feet per 1 mile. So let's use that. I have to decide, since miles is on the top and I want miles to go away, I put miles on the bottom here, or the denominator. I want to end in feet, so feet is going to stay on the numerator. And then I use my known fact that 5,280 feet is equal to 1 mile. I'm going to multiply straight across. I get 10 times 5,280, or 5280, with an extra 0. And that's how many feet per hour Jasmine is running. Our next example is a driving one. Driving 60 miles per hour, a car travels about how many kilometers in 2 hours. For simplicity, let's forget about the 2 hours. Let's just find in 1 hour. So we're going to find it per hour, and then our answer we can double to get that answer. So 60 miles per hour, that's given. How many kilometers per hour? So we're going to try to get to kilometers per hour. I always start with what I'm given, and I write down where I need to go before I do any calculations. Because how do I know what I'm going to calculate if I don't know where I'm going? Draw your unit multiplier box, and then decide what goes in it. Well, notice hours and hours didn't change, so don't convert your hours. But miles converts to kilometers. They give us a known fact that a mile is about 1.6. So since I want miles to go away, I put miles in the bottom. I want it in kilometers. I put kilometers on the numerator. See how it has to match, numerator to numerator? These we want them to go away. And I put in my numbers. 1.6 kilometers is equivalent to 1 mile. And I multiply 60 times 1.6. And that gives us 96 kilometers per 1 hour. Well, the question really wants to know 2 hours. So I'm going to take this answer and I'm going to multiply it. I'm going to double it. So that would be 192 kilometers for 2 hours of time. Make sure it makes sense. In 1 hour, you'd go 96. So in 2 hours, you would go twice as far, 192. Our last example is a RISE test question that's similar to what you're going to see on the RISE test. And it says this: a swimming pool is filled at a rate of 80 gallons per minute. Let's write that, 80 gallons per minute. I know I'm going to convert. It says, how many gallons is that per hour? So I need gallons per hour. Okay, notice, gallons and gallons didn't change, but minutes is converting to hours. We've done this before, just today. So we're going to put minutes on the numerator so that they'll go away. I want to be left with hours on the denominator, so I put hours in the denominator. I know a known fact, 60 minutes per 1 hour. Minutes are going to cancel, and I'm left with 80 times 60 gallons over hours. There it is. So 80 times 60 is 48 with 2 zeros, and that's my answer. But there's a few more parts to the question. How many gallons is that in 10 hours? So I'm going to think of this as an input-output, because it's asking me another one, 20 hours. So this would be hours, is my input. This would be gallons. After 1 hour of time, I know it's 4,800. After 10 hours of time, how many gallons? Well, I would add, or times by 10, add the 0. So 48,000. How many after 20 hours? Well, that's going to be double. So I'm going to double that. That is, so times by 2, that gives me 96,000 gallons. Then the next part says, use a graph to show this. We're going to do, it says the hours are on the x-axis, so this would be 10 hours. This would be 20 hours. And then this one is gallons. So let's start, we know at 10 hours, our ordered pair, our number there that goes with 10 hours is 48,000 gallons. So I know I'm going to have a point here. And then 96, we're going to go up to right here. Oops, right there. And then these are going to connect. Now, I didn't really do a super neat job, but they should be about a line showing a constant rate of change or constant filling of the swimming pool. But that's the type of graph you're going to do on the RISE test. We put in the concept of unit conversion, input-output tables, and graph them all in one question. And that's what RISE is best at. All right, hope that made sense.